Okay, in this video, we are going to talk about QQ plot, or the normal probability plot. That's the name on your textbook. So, if you guys still remember, when we try to conduct the hypothesis, the second step is to check on the conditions. So the conditions are the assumptions necessary for the test to be valid include that it is a random sample and the population follows a normal distribution. And how do we know whether the population follows a normal distribution or not? There will be very useful tool that we are trying to introduce here is called QQ plot. We mentioned this when we talked about the sampling distribution, when we were talking about how large the sample size n will be considered large enough. I said this depends on what your distribution of your population looks like. And over there, I mentioned about the QQ plot. I said we are going to talk more about the QQ plot, which is a very useful visual tool to help us make a decision on whether the distribution follows a normal distribution or not. So, what is a QQ plot? So a QQ plot, another word called normal probability plot, is a quantile to quantile plot. So it's used to check if the assumption that the population follows a normal distribution is reasonable. What they are plotting is the x-axis is the quantiles or percentiles of a standard normal distribution. So this is what a standard normal distribution would be like in your x-axis. So this is standard normal quantiles. The y-axis is the quantiles of the sample data. So this is the sample quantile. So this is the QQ plot of the coffee example that we have been using in this handout 10. So the x-axis is the standard normal quantiles. The y-axis is the sample quantile. And that's why it's called quantile to quantile QQ plot. And it's used to check for normality assumption. It's also called normal probability plot. So if you are plotting like this, if your sample does follow a normal distribution, then what would you expect to see? You would expect to see that the point will plot on a straight upward sloping line, right? That means the sample quantile is is roughly the same as the standard normal quantile, right? If all those dots from the sample will form upward straight line in this QQ plot. On the other hand, if the sample does not follow the normal distribution, then you would see the sample quantiles will differ a lot from the standard normal quantiles. Then you wouldn't see a straight line in your QQ plot. So if your points basically follow an upward sloping line, then your sample follows a normal distribution. And it's reasonable to assume that if your sample that you're collected from the population follows a normal distribution, then your normal will also follow a normal distribution. Thus, we could use it to check whether your population follows a normal distribution or not. This is the QQ plot of the coffee example we have seen. And looking at this plot, you kind of like say, yeah, I believe all those dots is reasonably to believe follow upward sloping line. So the normal assumption of this mean caffeine is kind of reasonable. So the previous procedures we have done about the hypothesis test are valid. So points basically follow upward sloping line. That means the normal assumption is reasonable. So there is one thing that I want to mention here. There are some students who have learned more statistics before confused about this normal QQ plot versus the regression plot that we are going to talk about later in the semester. That's not the regression line that we are not trying to fit the x-axis and the y-axis to find a best fitted line for those dots. We are just trying to see whether all those dots basically follow an upward sloping line. You will have a better understanding of this when we talk about the simple linear regression later on. So there are some pros and cons of this QQ plot. The big advantage is it's simple to interpret, right? You just try to see whether all those dots follows an upward sloping line or not. And it's quite straightforward, right? A visual check, yes or no. So simple to interpret, and you just need to look for a straight upward sloping line. There are also some disadvantages about this QQ plot as well. As we have mentioned in the advantage, it's simple to interpret, it's easy, you just look for a line. Thus, it's just a visual check. It is not an airtight proof. So some con is just a visual check, not airtight proof. So sometimes it's somewhat subjective. It's not very objective. Some people may think, okay, this is a good enough straight line. Some people may think, no, that's not good enough for me. So it's somewhat subjective. That's not a proof. There are also hypothesis tests regarding the normality, like what we have done to test for the mean. There are hypothesis tests to test whether distribution follows the normal distribution or not. That will give you a more objective answer. Another thing is it may not always give you a clear answer, especially when your sample size n is small. This is also associated with the subjective feature. Let's take a look at the example of what I've talked about. So here are examples of QQ plots from non-normal sample data. When your sample size n equals to 10, which is a pretty small sample size, you can see those QQ plot. This is a QQ plot for the gamma distribution. This is the QQ plot for a Cauchy distribution with degrees of freedom equals to 2. This is uniform distribution. This is for the chi-square distribution. They are all not normal distribution, but it's pretty straightforward to see. Okay, this is absolutely not a straight line. What you are trying to see if whether those blue dots are in line with this theoretical right line. If all the blue dots are in line with this theoretical right line, that means if it falls in the criteria that we use to decide whether distribution is normal or not using QQ plot. Those are kind of, those three are kind of obvious. For the first one, you are actually not having a clear answer, to be honest, right? You can't really say whether all those blue dots are close enough to this right line or not because you don't have enough sample size. Similarly, here are some examples of QQ plots, 2 on this page and 2 on the next page, from the normal distribution. So all those graphs are drawn from simulation data. Now those are really QQ plots that are generated from the normal sample. Again, your x-axis is the theoretical normal quantiles. Your y-axis is your sample quantiles. If your sample is coming from a normal distribution, we are trying to see that all the blue dots are very close to this theoretical right line. That is, if your dots are falling on this theoretical right line, then it follows a normal distribution. This one looks pretty okay, but it still may seem like there is some pattern. This one may also seem like a pattern of what I can't say, and this one, it looks too flat to me. So that's why I said here, if your sample size n is small, you can't have a clear answer. You can't really, you know, tell whether it's from a normal distribution or not, just based on this QQ plot. First, it's very subjective. Someone may think, okay, this is a pretty close, to normal. Someone may think, no, I don't feel so. It's quite subjective. Another reason is your sample size n is small. All the patterns are not very obvious, so that's some disadvantages about this QQ plot. So this is about QQ plot, and again, your textbook is called normal probability plot, and that's where you can read it. So the very last thing that I want to talk about regarding determining if the population is normal or not. So when your sample size n is small, the graph, we have talked about the QQ plot, all the formal normality tests may not be very helpful because the sample size is too small. You don't have enough sample size to establish a pattern yet. So some data from the normal distribution doesn't look like normal. Some data from a non-normal distribution looks like normal. So when your sample size n is small, either the graph or the normal test may not be very helpful. But, we mentioned when we talked about the assumptions of the t-test, that this normal assumption is quite robust. That is, even though your normal assumption is violated a little bit, it still are giving you a pretty good result. So when your n is small and you can't really tell whether it follows a normal distribution or not, you need to read and understand the context of the variable. So as long as the distribution is at least symmetric, then bell-shaped, then even though it's not exact normal distribution, that's also okay because the t-test is a robust test. And when your sample size n is large, your assumption about that the population is normal doesn't really matter as much, because remember the central limit theorem that we have talked about? This holds for sample size n large enough. Usually we use the rule of thumb for n greater or equal to 30. Then no matter what your population distribution looks like, your sampling distribution is going to be approximately distribution will be approximately normal. So you should be good. And if it is not reasonable to assume the population is normal and your n is small, then you can't use this t-test. You have to use a non-parametric procedure. So this is the end of the handout 10 regarding the hypothesis test for mean. It's a pretty long handout. That's why I broke it into many small videos. I will stop the lecture for today's class here so that you could have some time to work on it. And since we are doing this, pre-recorded lecture right now, it's really kind of your own pace. So I will not record more lecture for today. We will start handout 11 on on Wednesday. Thank you.